Hello everyone, Cal Gong. Let's start working on the lifecycle limit. Actually, for the lifecycle, we just need to add this line in the version. And it actually has a parameter like this. In our actor, how long will this actor survive before it dies? Its default value is 0, because we know that a property will digitize this number to 0, right? And this thing should be an initialization value. Should not be modified once play. Once the game starts, you should not modify this value, so you should set it in the constructor. So after we set it to 3 seconds like this, then actually after 3 seconds, this actor will simply die. Then we can check whether it has died. Okay, we are testing here. Pay attention to the left side. We shut out several classes. Let's take a look. Right, the joke is completely fine. Okay, so next let's look at regarding this collision part. As for collision, actually everyone please note, you will find that the document at this position is incomplete, although it has Chinese. We can also continue setting it in Chinese. But actually, if you switch it to English, through this place, the language section, after you switch to English, you can actually see its corresponding images. Actually, this is related to weather. This link can be accessed correctly. Okay, so we want to create a collision here. Actually, where is the collision setting? In project settings. Then under engine's collision section, and here we have some presets, you will find we can observe carefully. If you observe, there is a feature here. That is, if you set up a detection channel here, you can see you'll have 18 detection channels. You can make modifications and optimizations here. Then, after you add it here, for example, let's give it an A1. Right. But in C++, it is not actually called A. It is actually called, I think it might be called octa channel line, or maybe 11. I don't quite remember. Later, if this is used, I will explain it to you. Then later, if this is used, I will explain it to everyone. So it means there is a file. There is an NITXT file used for mapping, that is when you are in Blueprint. It is very convenient to use ray channels, but in C++, you need to check it yourself, what this channel actually corresponds to. Wait for me to tell you, it does not correspond to this channel 1. You just need to know this, okay? Then next, we will create our object channel. So how to do it? First, we create a channel of the object type. We call it Projectile, PCTILE. Okay, so the default is 1. This PyLEC do defaults to a situation where all main colors are used. Then in practice, we can make a simple preset file here. This file, we also call it project settings. Or rather, we should call it this PCTILE. We give it a file like this, then its collision enable status should be collectionemo. That means it both queries and supports this physics situation. Then its object type should be a project settings type. And it will register all of them. Here, we can add a registration called R project DC type collision per file. Okay, that should be it. Let's click OK. That should be fine. This way, it will handle all main shots. Then we need to do it in Blueprint. Actually, we can specify this in Blueprint. We can also specify it in C++. As for the specific method of specification, we can specify in the constructor. Similarly, right here, after setting the HUD, we will have a specify this collision body configuration file. Specifically, you can see it here. It has an body instance. It is inside the explosion blueprint. And here, it has a collision configuration file setting. You just need to pass NT8. I really want us not to call it this name. Now we should be on this. It should be called this name. Okay, we are on it. Then at this moment, we made a simple collision detection thing in our scene. A simple collision detection thing. Next, we can add a hit effect to it. We can add a hit effect to it. The hit effect, how should it be written when it is correctly determined? Actually, we also need to do this in the constructor. The way to handle it. because we have a collision body like this. Because we have a collision body here, we can put it here. Then here we add a dynamic such an event. Then remember to modify it. We don't have this function yet. This way, it will report an error. So why did I write this first? I'm actually telling you how to do this thing. Where did this function name come from? Go to our collision box. You should have done this collision in Blueprint. And actually, it might be in the parent class. Yes, then it should have one. There is a collision-based multi-wave proxy, then a dynamic multi-wave proxy. It's not easy for us to find. We'll find it this way. Let's click on it. Then click on it. We can take a look. It's not here. Then it should be in the parent class. Not in the parent class either. Then it might be called parameter here. Then let's press enter like this. You will see there is a struct here. This struct means when we make the call, when a component has this collision, hit something hard. And then it can, often due to the player's movement, that is to say, this is related to the lack of swap following or some overlap event. It often gets triggered and its function signature. You see, this is very important. This class Fermi's component is very important here. Okay, so we haven't talked about delegates yet. We will cover them later. Actually, this is a declaration of dynamic multicast for this group of declarations. I don't know what this sports thing is. This part of his is a dynamic multicast proxy with 5 parameters. And then the name of his proxy. The name of his struct is called it. And then it supports 5 parameters. And note that between the parameter and the parameter name, between the parameter type and the parameter name, we separate them with commas. This is different from functions because its essence is actually a macro. It helps you declare such a proxy. So it must start with f. Must start with f. Then the first parameter is this component. That is a component of this uncomp. And this is the collision component of the hit. Then this place is an actor. And this is another such component. And here there is a factory. This is something related to impact. And this is the result of the hit. Okay, so this is its function signature. So how do you declare it? Actually, it's very simple. You copy this over. Because it must match this function type signature, only then can you bind it to this dynamic multicast delegate. Yes, okay. This. So we can paste it over. Actually, it looks like this. It requires such a supports these parameters passed from these functions. And then here we declare such a parameter. Note that it must have square brackets because it is dynamically multicast. Dynamic means it needs to be dispatched. You can see here it is a one-to-one correspondence. Such a relationship. Here you can see this is 1 parameter, 2 parameters, 3 parameters, 4 parameters, 5 parameters, 5. Right, these 5 parameters. Click over and take another look. Okay. Then at this point, compile it again. It should be fine, because it can match up. We can go back and take another look. That is what we moved over. Pay attention, this place is 5 apartment, but here it uses a spice. Then you'll notice that it actually one disu object like this place. It should be this thing. It indicates that it is written in this position. Yes, this should indicate this. And actually, its real parameters are the following 5. 1, 2, 3, 4. Yes, because you can see if you observe, because it is different from our usual one. It seems different. It has an extra one here. So it should indicate this attribute. So if you paste it over, this method, this detail is right here. This thing is actually not needed. These first 3 are not needed. Then the actual ones after this, the 5, because 5 form, you know, this is the one that is your actual function signature that was made. Then in this place, you can achieve such a hit effect. Okay, then when this hit occurs, we can trigger some events. Obviously, when we hit, after we finish hitting, we definitely need to destroy ourselves. Because the bullet is destroyed immediately after hitting, you can generate some particle effects, or play some sound effects, or apply some decals. This kind of snowblade effect, you can do all of this here. Then, we need to determine whether this actor as the hit object, it is not equal to itself, that is you colliding with yourself. This situation usually occurs under what circumstances? It could be that you have multiple components with collision enabled. They might collide with themselves. This is possible. And then this component that was hit, it needs to support simulated physics. Only if simulated physics is supported can we drop this component. That is to say, this component is a very important one. It is a base value. It uses sync complement. But it contains some geometric properties that can be rendered and can also be used as collision data. And here, there are some very obvious derived classes, such as our shape, its shape complement. We convert the collision capsule focusing software. We often do damage detection. Then the collision mesh and the Google mesh thing. The difference between collision mesh and Google mesh. Everyone should be clear about the distinction. Just one person. Simply put, one person moves, the other cannot move, and then this part is just supplementary information. Then here, you need to enable collision. Only then can you call this method. And as for this method, it simply adds a rigid impact, such a force that can make it move. That's roughly the situation. So with this code, after we finish writing it, we can then go ahead and do a simple demonstration in Blueprint. Okay, so let's come here. We'll give it a cube, and here we just drag in a cube randomly. It might not look exactly the same. Then this, if we make some adjustments here, let's take a look here first. We might need to make some adjustments to his path. We need to make some adjustments to the state machine. Let's show him by turning on physics. Simulate physics, okay. Then after we turn it on, it will fall down. Hey, is it on? Right? It's completely fine now. That was a bit too strong. We sent it flying directly. Okay, so we finished verifying here. Finally, let's drag our stuff through the HUD. Drag this thing we call it 中景, okay. Similarly, if we need to import some assets, we originally have a texture. We will create a texture. We give it a texture 2D. Usually we just say texture. There is actually a lot of knowledge about textures to tell you. The ones we use most often, there are render targets and capture 2D. This is a very commonly used thing. It might need to be covered later. We will give a practical example later. Then here, we import this asset. It has a ITGeo extension. Usually we use PNG or JPG, right? So it comes in like this. Of course, this naming is definitely not up to standard. The proper naming should be crosshair. I don't know either. Let's just leave it at that, okay? Crosshair. And then you need to know this knowledge. You need to understand this knowledge. It's these, some compression methods. And then is this place RGB? Generally for normal, besides face color. We usually check, but sometimes it might be different. We do something like transcendence or discovery and such. This place might not be enough. Specifically, it depends on our PBR rendering standard specifications. This part is included in our official documentation. These are some groupings. So this thing is quite important. Some related settings within these, we often use them. Okay, now that we have it, we are going to start making our HUD. Team insurance. Then we need to write the HUD. So there should be a HUD here. You see, it's a very commonly used class. We call it BP. No need for BP. FPS HUD. Okay, then we'll just create it here. And actually this HUD has already been created. It is the base subhead. We need to override it. We'll ignore this leave encoding for now. Let's discard this. Override it. Okay, we base the subhead HUD. This class is actually a bit awkward. Its positioning is actually a bit awkward. But well, let's see if this works. Added and switched over, it works. You can see this is a head-mounted display, head-up display. This has a canvas, and this also has a debug. Canals is something that is being rendered. It can contain a series of these head boxes, and then you can use some simple click tests. And there are also some rendering methods that can be used. You can render some circles, textures, or rectangles, or materials, and then we can access them through our blueprint. So this is our HUD. You need to note, sometimes our HUD does not support TIC. Actually, you should pay attention that sometimes it is not supported. You might need to keep this in mind. Okay, so once we have the HUD, we definitely need to specify a texture here. We want this texture to be specified through our blueprint. So we edited a pointer like this. Then, if we want to continue working here, we need to grab the HUD. We can see that after we click on it, there is a drew part here. We might be here. It is something that drives every frame. It allows us to draw something on our HUD. So we need to override this method. As for its call timing, we don't need to worry about it because it's obviously handled by the engine here. The engine goes to investigate for you, right? Look, there is some processing here. Okay. Obviously, we can see, actually there's also one here. Reserve. This has been explained to you. This is implemented in Blueprint, right? And it only executes on the client because HUD UI. You need to know HUD is not present on the client. Not on the client side. It does not exist on the server side. So this is a noteworthy detail. Okay, next we will write our function related. First, we must call the parent class. If you don't call the parent class, there will be some issues. Specifically, what issues will there be? That is, if you don't execute super begin play, you will find that your actor doesn't tick, or your actor's components don't tick. This is something I remember quite vividly. And if you don't execute this, some of these things might not be released or cleared. This may cause some issues. Obviously, you are not executing this super, and obviously this function of yours will not execute. So if you do this in the blueprint, that is, if you override it in the blueprint, then it becomes meaningless. Therefore, this super is very important. We have emphasized this once again. Actually, we just need to extract this piece of code. It should be simple to take a look. That is, if this textures exists, this canals, we might need to put this canals here. Yes, why is that? You can see it is something from UK knows, and you can see it is in our negative class. What is it? It inherits from Ambash. It is a KROS, a canvas, right? You see this UK, and this place has many methods, right? Okay, we can ignore it. Then in this place, this place is equivalent to it going. Offset this a bit. The position of the texture like this. Do a simple calculation. If you don't do it, then it's very likely that the top left corner of the texture will be placed at the center of this canvas. So for this offset calculation, we can just copy the node. No need to think too much about it. And then mainly this place is throwing an error, right? The reason for this error should be very clear because obviously our UText2D, we did not import it. Actually, sometimes in what other situations does this still occur? That is to say, sometimes we will retrieve this, the aforementioned value, etc. You will find something. That is, there is a rounder. This thing called rounder queue. If you don't import it, sometimes it will cause problems. These are some small details. If you encounter it often, you will know. That is to say, why is the same code? You might miscalculate the addition. It's this kind of problem. Obviously, an ending needs to be added here. Okay, let's take a look. It will still report an error because it's like this resource. We can take a look. Let's find this texture. What exactly is this resource? Or let's directly look at this struct. Its parameter. It's this thing, FTexture. This thing, FTexture. Where is it? You'll find it in the render source. Let's open it and take a look. It is in render queue. Then publishing the render source. Obviously, we should modify our build.cs here. Then we might need to include here. Actually, including it now probably won't help. Yes, so we need to try to fix this issue. This is a good issue to demonstrate to everyone. So let's directly add something called renderpill here. Okay, now let's go back here and compile again. it still reports an error here. If it still reports an error, let me check again. Alright, let's do it this way. Obviously, here, he must have changed it. What's it called? Let me put it another way. It means it no longer has the original variable. It changed it for you. This reason for version changes is very normal. So this code of ours, this piece of code doesn't need much explanation. This part is just for drawing. And actually, sometimes we draw the map. You can do it this way. But I think this might be a bit troublesome. You can use the material approach. That is, on a texture, and then draw on the material, drawing some things related to the player. This way might be better. If you use HUD here, it will definitely, I think, the code you wrote. Yes, okay, so now we are finally almost done with this section. And now basically, we have finished all these tasks, and now we need to create our specified resources. Actually, how Blueprint and C++ divide the work is like this. Most of the logic goes into C++, and the resource configuration goes into Blueprint. Then here we find our own HUD. We add bpxg HUD. Okay, then we need to specify it here. Specify it here. You need to note that you often use game mode and camtate, or game HUD, or UI boutique issues. This is very normal. You might not have it turned on, because I often had this confusion when I was learning Blueprint. Then we can see it's normal that there's nothing here. Why is it normal? Because you haven't specified it yet. It's an empty source, okay? So this section basically concludes our discussion. In the next section, it's actually about animation. Actually, we'll just go over it briefly and reproduce it for you. Okay, the pressure shouldn't be as high now. It seems there's still a bit of an issue with the collision here. Let's check it. This might be related to the type of floor. It's a small collision setting. That's blank. Okay, then let's not worry about it. Let's stop here for now. Thank you, everyone.